Let's evaluate the limit. Limit as x approaches infinity of x times pi over 2 minus 1 over x minus arctangent 3x. So x approaches infinity, so this will go to infinity. 1 over x goes to 0. Arctangent 3x goes to pi over 2. And obviously this also goes to pi over 2. So you have pi over 2 minus 0 minus pi over 2. These will just go to 0 then. And essentially you have infinity times 0, which for L'Hopital's rule, you want to get infinity over infinity or 0 over 0. And that's going to force us to divide by the reciprocal of one of these two. So the question is, do we divide by the reciprocal of x or what's inside the parentheses? It's a lot simpler to divide by the reciprocal of x. And x is this one. So basically you'll do 0 divided by 1 over infinity, which is really 0 over 0. And so now I can use L'Hopital's rule. So let's first divide by 1 over x. And now this, obviously, we said is 0 over 0. So we'll take the derivative of the top, which is 1 over x squared. And then the derivative of arctangent 3x is 3 over 1 plus quantity 3x squared, which is just 9x squared. And the derivative of 1 over x is negative 1 over x squared. And really, I'm dividing by negative 1 over x squared, which is really the same thing as multiplying by negative x squared. So if I'm dividing by 1 over x negative x squared, that's the same thing as multiplying by 1 over x squared. Or sorry, multiplying by x squared. Negative x squared. Okay. All right. I'm going to distribute the negative x squared. So 1 over x squared times negative x squared is negative 1. And then negative 3 times negative x squared is positive 3x squared. And that's going to be over 1 plus 9x squared. Obviously, we have negative 1. And then as x approaches infinity, well, I can basically divide everything by x squared. So, intermediate step here. And then I'm going to have plus 3 on the top. And then 1 over x squared goes to 0. So 0 plus 9. So you have negative 1 plus 3 over 9 is 1/3, which negative 1 plus 1/3 gives me negative 2/3. And so that is going to be my limit.